Hello and welcome to Martin Maths, doing a video on quadratic sequences. So we have a sequence 3, 12, 25, 42 and 63. So that's my n equal to 1, my first term, my second term, my third term, fourth term and fifth term. Now we want to find a sequence that'll generate that. So the first thing we do is we find what's called the first difference, meaning we subtract term by term or see what's between them. So 3 to 12, 12 to 25, 25 to 42, 42 to 63. And we can see that that is 9, 13, 17 and 21. So we know it is not linear because they are not the same. So then what we do is we find the second difference, finding what's happening between these terms. So 9 to 13, 13 to 17, 17 to 21. And we can see that there's a difference of 4. We're adding 4 each time. That means we're dealing with a quadratic sequence, a sequence that will involve n squared. So let's look at what we have again for our terms of 1, 2, 3, 4, and 5. Those are all our terms. We had 3, 12, 25, 42, and 63. Remember, n squared, 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we're not anywhere near that sequence just by being n squared. So what you have to do in the third step is take half of that difference as the coefficient. Take half of the second difference as the coefficient. So half of 4 is 2. So we're going to do 2n squared, meaning 2, 8, 18, 32 and 50. We're getting closer to that. Now what you do in the fourth step is you see what you need to add to get to the original. So kind of see, check what is needed to get to the original. So if I look at this, I would need to add 1 there, I'd need to add 4 there, 18 to 25 I'd need to add 7, 32 to 42 I'd need to add 10, 50 to 63 I'd need to add 13. And you look at another difference here. What's happening between these? You can see they've all got a difference of 3. And this is the linear part. Let's use the writing there. So now we have something we're adding 3 each time. So we've got a sequence now of 2n squared plus 3n. We're increasing that each time. So let's see, is that getting us back to what we want? But if it's not, then we're going to adjust it. So if I put in for 1, 2n squared give me 2 plus 3 is going to give me 5. So I'm too high. So for the fifth step, you just have to adjust. So if I have n equal to 1, I'd have 2 times 1 squared plus 3 times 1 and be 5. And that's not what we want. So we need to adjust that by 2. And that will be our sequence. And you can check it with the second one. Say n equal to 2, 2 times 2 squared plus 3 times 2 minus 2. So we'll have 2 times 4 plus 6 minus 2. That's going to be 8 plus 6 is 14, minus 2 is 12. And that is what we want there. So let's go over that again. I find the first difference. I then find the second difference. I take half of that second difference as the coefficient. So I'll try and use the same color there. Half of that 4 goes there. I then check what's needed to get back to the original, and that's this bit in purple. I need to add 1 there, I need to add 4 there, and that's the linear difference, so that's that bit there. And then the last thing I do is just make that final adjustment to see that that sequence is back to the original, and I subtract that too. So you have a quadratic sequence and a linear sequence within that. Hope that makes sense. Thanks for watching. Don't forget to like, subscribe, and share.